This is the Inquiry Lab on page 535 of your book. We're talking about similar triangles. So have you guys ever flown in an airplane before?
Yes.
So this is, if you have, fantastic. If not, Ariel, ironically, because that means flying in the air. She was looking out the window when she was flying and she saw some fields like this. And because Ariel's awesome, she decided to math the heck out of it. So what she did is she drew this diagram on her paper and labeled everything. And then she noticed that there were two triangles here. So we have this triangle. We have this little baby triangle LMN. And then you have a bigger triangle, triangle LQP. So she's like, I wonder if there are any relationships between those two. So she got out her protractor, and because again, she mathed the heck out of it, and she's really awesome like this. And she got out her protractor, and she measured the angles, and she measured the sides, because her protractor had centimeters on it. So this is what she found. So you guys are going to fill this in. She found that LP, so the distance from L to P, was 18 centimeters. Then L to Q, you guys are writing these down, right, was 21 centimeters. Then P to Q was 25 centimeters. I'm just going to keep on going with the lengths. Then LM, so like the little guy right there, was 9 centimeters. This was 10.5 centimeters. And then this was 12.5 centimeters. Guys staying up okay? So just filling in those centimeters. And then she measured the degrees. She found that angle L, what she saw was on both triangles, was 78 degrees. So see how I put them twice, once here, once over there. Then she measured P, angle P, and it was 58 degrees. And then the measure of angle Q was 44 degrees. And she was kind of surprised because then she found that angle M was also 58 degrees, and N was 44 degrees. Oops, I meant to put degrees there, and they already had the degree sign. What do you notice about the measure of the corresponding angles? What do you notice about these angles? So they're the same. They're the same. And then she started looking at the ratios of the sides. How long is LP? 18. How long is LM? 9. And what is that ratio? 2 to 1. Good. So LQ, how long is LQ? LQ? 21. How long is LN? 10.5. And what is 21 divided by 10.5? 2. So it's 2 to 1 again. So then what do you think this next ratio is going to be? 1. What? That's 12.5. And that is also 2 to 1. So what do you notice about the ratios? They're all 2 over 1. Nice. And it is exactly just that. It is a dilation, and which is what we're going to be talking about with similar triangles. So here we have this triangle ABC, and they tell us that this measure up here, angle A, is 53 degrees. So you're filling in that 53 degrees. And then it says you get to take this, so they already drew this here, which this X is also 53 degrees. And they said you get to draw these triangles however long you want to make it. So you can like go all the way down, or you can just put a line to connect them. Like, what do you want to do?
Go all the way down. Line to connect.
I think a line to connect them is really easy. You guys agree? So then we're going to have to label this one. If it's supposed to be XYZ, similar to ABC, then what should this point right here be? Y. And then this one? Z. And while we're at it, before we go on, how can we find the measure of angle B? Oh wait, what does it say angle A is? C. If these are a right triangle, what is angle C? 90 degrees. How do we label that?
With a square.
With that square thing. Then it's nice when it's on a graph because you can just use the lines of the graph. And then put the little square on Z, right? So how are we going to find angle B?
Subtract it from 180.
But because we know that both of those have to add up to 90, so I can just do 90 minus 53. That's supposed to be degrees. And you get 37 degrees. So I'm going to label this one as 37 degrees. 37 degrees. Okay. Now we are totally set up to answer a ton of questions. What do you notice about the shape of the triangle? So you put same shape. What is the measure of angle B? Oh, we just found it. What was it?
37 degrees.
37 degrees. What is the measure of the angle that corresponds to angle B in XYZ? So first of all, which angle corresponds to angle B in XYZ?
Y.
So watch this. This is how we can do the abbreviations for the measure of. Yep, that was fancy, right? The measure of angle Y is equal to 37 degrees. Don't you like that? Instead of writing out the measure of the angle, you can just do M angle Y. That means the measure of angle Y. Okay, looking at the pictures, and I'll leave it for you to look at the pictures. Maybe I'll zoom out just a little bit. What side goes with AC? AC. On this triangle, which side goes with AC? XZ. And let's just keep on going across. Which one goes with CB?
ZY.
CB goes with ZY. And then which one goes with AB?
XY.
XY. Good. Okay. How long is AC? This is what I like to do. I go 2, 4, 6. So I can see that it's 6. And how long is XZ? 3. And so 6 divided by 3, what does that reduce to?
2, 1.
2 over 1. Nice. If we made it bigger, it would just be a different fraction, and that's okay. Right? Yeah.
So if it's a plain number, we have to put the 1 at the bottom?
Over 1. Yep. The ratio will be over 1. Yep. And then CB. How long is CB? 8. And how long is ZY? 4. And what does that reduce to? 2 over 1. What do you know? And then AB. How are we going to do AB? AB is a diagonal one. That is the hypotenuse. So we're going to have to do the square root of the leg squared plus the leg squared. So for AB, how long is this leg? 6 squared plus, and then how long is this other leg? 8 squared. And it is indeed 10. Because you get the square root of 36 plus 64, which is 100, and the square root of 100 is 10. And then the other one for ZY, it would be 5. Because the legs to this thing are 6 and 8. So that was also 2 to 1, so they are similar. So what do you notice about the ratios? They're all 2 over 1. Nice. Okay, that's all we were doing with that one.